talking about DT first, to revisit it, very important DT, is that the advantages that we have, one, as I said, transmit and receive and the same transducer.
Mm-hmm.
Yeah.
Okay, so instead of through transmission, two different transducers. So that's very important. Second is no transduce, no sample cell opening for transducer. Or let me rephrase that. Maybe say it a little better. Transmit and receive, so it's a mass, right? Mm-hmm. And mass also. Reflector through top of liquid or top of sample. That means that we have the sample cell and we have our transducer here and we have the reflector here that moves.
Yes.
So this is mass, but DT goes through the wall, yes. So needs to have an opening here and another opening here, and through transmission. So you have a problem with two different transducers making measurement,
Mm-hmm.
but also you need O-ring here, and these are always samples. Samples are abrasive with particles, and so this O-ring ends up failing. So you have leaks. Has to be replaced. You lose alignment when it's working, and you have to realign when you replace transducer. So it's those are two big advantages. And there's one more advantage that for mass, which is the software, the particle size software. Size software. That the calculations that a mass makes no assumptions regarding the shape, meaning if it's Gaussian or log normal Gaussian, or log normal, or unimodal, or bimodal. No need with the mass software. No assumptions. But DT have to guess or know sample is Gaussian or log normal or unimodal or bimodal. So you don't know if accurate. And therefore, because what happens is when you have a mean particle size, say 100 nanometer mean particle size, you can have in any of these shapes, you can get 100 nanometers. So you don't know my sample particle size like this, or like this, or like this, or like this. With DT, you don't know. And with the mass applied science algorithm, you know which shape for the particle size distribution.
You mean DT only can measure the mean?
Yeah, DT really measures the mean, yes. Yeah.
And then we can see the distribution of a part.
For the mass applied science, it's mean, but also particle size distribution shape. Both. DT only mean, really. And guess.
Guess.
They are guess.
Yes.
But we can measure the real distribution.
Exactly. Or I said true distribution. Yes.
True distribution.
Yeah.
Okay.
So those are big three advantages against DT that you can use against them. And they're using against us sample volume. But now with DIP probe, we will DIP probe that we will have a decrease the sample volume. But also another number four advantage. Well, open box here. Number four advantage is their sample cell has weak mixing. So a mass has an efficient sample mixing. The DT sample cell is uses magnetic stirrer bar.
어.
No, not really like this one, more like this.
搅拌棒，那种搅拌
那
棒，
个磁
搅拌
那
搅拌
个不是
搅拌
在下面，对
搅拌
磁
那种
石的，
对
对。
So it's weak.
嗯
So for high concentration, it's not enough.
那种
，OK，
And so this is another advantage for sample mixing because when you make a sample measurement, you need to have the particles suspended so that you can the sound can travel through the particles. But if the sample cell it doesn't have enough mixing and you have the particles here and the sound is going here, then you don't see sound does not see the particles. So you don't want particles settling. And so that's a big advantage because mass has a mechanical mixer.
Yeah.
So that's another important advantage mass applied science has. So there's four important advantages over them.
OK，
Okay, this is very useful when we
Thank you. Yes.
customer the office,
Yeah.
and we can tell they we have 4
Yes.
Advantage.
Yes. Exactly. Okay. So now we'll go and so make sure you you get the